Hey, Anne, do you have any plans on April 28th or April 29th?
I actually do, Ruby. I am going to be a speaker, which is like one of my favorite things to do.
Oh my goodness, me too. I'm going to be at the Seattle Reproductive Symposium.
That is where all the hip healthcare providers are going to be this April. So if you are one of our many listeners that is a provider, we want to share with you the opportunity to get in on that early bird pricing. Up through March 27th, you can sign up at a discounted rate, and it is such a great thing to give to the community.
That's right, and it's up to 11.5 AMA Category 1 credits, and there will be 5 of our previous guests from our podcast speaking. So Dr. Nicole Barker, Dr. Sarah De La Torre, Judy Simon, Laura Hayden, Kristen Chambliss, among many, many other wonderful guests.
And we have some hands-on workshops. So the Thursday before, there's an ovulation planning workshop, and that Saturday afternoon, there's a workshop all about doing IUIs or intrauterine insemination. So if you are a healthcare provider either in the Seattle area or interested in coming to the Seattle area in April to meet us, find the full agenda, register. Everything's online at seattlereproductivesymposium.com, and we are accredited and hosted by Seattle Reproductive Medicine.
Welcome to The Whole Pineapple. I'm Ruby Boris.
And I'm Ann Judge. The Whole Pineapple is a podcast about wellness focused around fertility. We'll talk with experts on a wide range of topics, including nutrition, stress relief, sleep, mental health, etc.
And we'll dig into the issues that can cause fertility challenges, like PCOS, or early menopause, or cancer treatment.
So if you're curious about your fertility, whether you're ready to start a family,
or you're preserving your options for the future, let's dig in. And you know how I love the 90s, right? The music, of course, analog was still hanging in there, but there was a lot happening in science in the 90s. And there's a couple things scientific events that stick out in my 90s memories. And one is the Hale-Bopp Comet, and the other is the Human Genome Project. So it started in 1990 and ran through 2003. And I just remember how incredible everybody thought it was. It was actually one of the first early experiences that got me interested in health sciences. And I remember the teachers being just pumped about this DNA thing. And there were so many lessons about it in science at class. And then I remember President Clinton talking about it when it was finished. But what is lesser known is what followed, the Human Epigenome Project. And we've talked about genetics recently, like the nature side of that nature-nurture debate. We've talked about nutrition and its importance on health and fertility. What exactly does epigenetics mean? Why does our health go beyond our genetic code? And why can our lifestyle impact not only our health, but the health of future generations? We're going to talk with an epigenetics expert today. So fair warning, before I introduce our guest, I'm going to be in just full-on geek mode today. So Kent Thornburg is a PhD professor emeritus in the Department of Medicine at Oregon Health and Science University, just our neighbors down the way. He serves as the interim director of the OHSU Knight Cardiovascular Institute. He studies how early life stressors set a person's risk for adult onset diabetes and heart disease. He and his colleagues are laying the groundwork for understanding the origins and progression of heart disease driven by epigenetics. He has received local, national, and international awards for his contributions to the field. He serves regularly on advisory panels at the National Institutes of Health, the American Heart Association, and the Children's Heart Foundation. Dr. Thornburg chairs the external scientific board that oversees the nationwide NIH program entitled Environmental Influences on Child Health Outcomes, or ECHO, as well as the Canadian Genome BC Epigenetics program. He has given many talks about this topic, including one for TEDx Portland. Dr. Thornburg, we're so happy to have you here.
Thank you so much. It's a real privilege to be here, and I'm overjoyed with the work that the two of you do.
It's been fun learning all the different ways that health impacts our fertility and how we're more than just our reproductive years. And epigenetics is really one of those things that combines both reproduction, but also just lifelong health.
Ruby, where do you want to start? I know there's so much we could talk about.
I think we should probably start with what the health trends have been like in the last few decades,
Since the 90s?
Since the 90s.
Since we started with the 90s?
Yeah, honestly, it's I think the 90s is about when we started to get a lot more processed foods and things. So Dr. Thornburg, tell us a little bit about what the health trends have been like.
Yes, you're asking a very good question. And that question is a driver for a lot of the work that I do. So if you can think back 3 generations, you're better than I am if you can remember that far back. But it turns out that that is when we in the United States started eating ultra-processed foods. But the food industry has ultra-processed many foods now and made up foods that nobody ever thought of before. And those are often laden with sugar and chemicals, fat and salt that are very unhealthy. Now they started advertising those in the late 50s. And I love to go back and look at those food ads from a long time ago. They're actually hilarious to look at now.
Yeah, do we have an example? What's like the first ultra-processed food? What was it? Was it a meat thing or a sugar thing?
Like a Spam, yeah, or cheese.
Spam is a really good example. And the processed meats have been shown in the meantime to be harmful to people if they eat them a lot over a long period of time. But the point I want to make is that we all started depending on industry to help us choose what foods we want to eat. Before that, we went to the garden and we ate foods that we traded with our neighbors or we canned ourselves, and we ate much healthier than we started to do in the 60s. And because of that, the numbers have gone up and up. And ultra-processed foods are foods now that you can buy in a packaged meal that are made. They have all the salt and fat and sugar that you want, or even if it's not good for you, and that you then start eating those things. And those foods have continued and have increased in their consumption rates. This has been very good for the food companies. And I don't begrudge them making money. But it turns out that what's happened over 3 generations is what I call the epigenetic burden. And we'll have to talk about that maybe a little bit more, but just let me say this. All of us are the product of our heritage over the last 3 generations. And each generation that eats these processed foods, we think, adds more to the epigenetic burden of that person and makes them more likely to suffer disease like diabetes and obesity. So I'm going to draw a graph for you just by describing it. So imagine a line that's going up slightly, which shows the increase in the rates of diabetes in the American population. And we're going to start back in 1958 or 1960 when the records were started. So I just want you to see this line going gradually up. And then in the mid-90s, all of a sudden, it jumped up and started going up very rapidly. So now it's going up steeply, and it's been going up like that until today. And that's the rate of people acquiring diabetes over that period of time. Right now, the American Diabetes Association suggests that there are 30 million people in the United States that have diabetes, and it's approximately 11 to 13% of our population. I'm a person who can remember way back after World War II when I was born, and I could tell you in my class, growing up in grade school, we didn't have any kids that were overweight, and I'd never heard of diabetes in a child. Now we know that there are large numbers of young people who have diabetes, and this is mainly driven by epigenetic changes in their vulnerability for disease that have occurred because of these foods over that time. So what's happened to us? Our rates of obesity and diabetes are going up in our population, and the population as a whole is becoming less and less healthy over time. So about a dozen years ago, we started predicting that life expectancy had to start going down because of all these numbers. We were surprised that it didn't go down sooner than it did, but it started in 2016, and life expectancy started declining at that period of time. And then along came COVID and added even to that. So life expectancy has gone down fairly dramatically in the last 5 or 6 years. And what that means is that babies born now are likely to die at a younger age than their parents. And that's really a sad note about the health of Americans.
Well, obviously, a lot of things have changed between 50s, 60s, and now. How does the data kind of focus in to talk about processed food? How do we know that that's the main driver of these increased conditions?
That's a great question because there are many reasons that people become diabetic or obese. It's complicated. And some of those things that you're mentioning include we've become more sedentary. Children don't play outside like they used to. And I used to play outside till it was dark and my parents made me come in. I don't see that so often now. So younger people don't get the exercise that they used to. Well, I guess older people don't either. And because of that, the exercise piece of it is significant. The other piece of it that hardly anybody talks about is social stress. And people who are not sure if they're going to get the next meal, if they're going to have a place to live, housing insecurity, and people who are suffering violence. This stress leads to changes in epigenetics that also adds to the food.
Well, I guess we should go back a little bit. How would you define epigenetics, just so people know what we're even talking about?
Oh, yeah, good idea. Well, we've already talked about the Genome Project. And by the way, I was one of those people excited about the Genome Project. And it turns out that what was promised was that we would know every gene that would help us understand why people get disease. Well, it turns out that's not true. But it did deliver something that's just as important. And that is that now we know a lot about people's genomes and which ones make them have a propensity for specific diseases. So that turned out to be good. However, what it didn't take into account is that what really matters is not just the gene code you got from your parents. It's whether those genes are turned off and on at the right time. I just want to go back and say one word about genes. Genes are a code on the DNA that we have in all of our cells, and about 80% of that code is used in developing us through our developmental phases, all the way from fertilization up until through childhood. Those genes are really important, and they regulate the way we grow and develop. Epigenetics, though, is a process, a chemical process that can change the way those genes get turned off and on. And epigenetics can chemically change a gene so that it's expressed more than it should be, or it can silence a gene that needs to be turned on during our development, but it isn't turned on as much as it should be. And by turned on, I mean that it's what a gene does is codes for a protein that cells use in order to help us not only develop as an organism, but also the way we use food and our metabolic properties.
Yeah, because we used to think it was like if you had a gene for something, that meant that was what you were going to express or behave.
Well, what we do know now is that a family history of any particular disease does not necessarily mean that there was a mutation in that family in their genome. It can be an epigenetic effect that is also passed on from one generation to the next.
And that really is a big overlap, because I think we thought back in the day that once we understood the genome, that genetics were just our destiny. And that was going to be how we'd fix everything. We would finally decode the genome, and then we'd find a way to just turn off the bad genes and turn on the good ones. And then epigenetics basically shows how much more complicated it is.
Yeah, that's right. But one thing I think a listener ought to know is that the nature-nurture debate is now being seen as being virtually worthless as an argument. Because we are all nature and we are all nurture, and they're equal in their importance. And epigenetics is the nurture part of it, the environment that changes the way our genes work, but you need to have healthy genes in the first place. So it turns out that they work together and there's no way to separate them except in arguments when you have at parties.
Well, it's also interesting because as fascinating as the genetic science is, even though talking about it as epigenetics is newer, I mean, these are concepts we've studied for a long time. Back before we had the genome, they'd look at twin studies where a twin was adopted out, and they would say, well, wait, if these are identical twins, why does this person have that and that person doesn't? And I mean, that's always been the nature nurture, is that it always is something in the middle. Do you want to talk a little bit about some of the early population level studies like famine research, or kind of when people were first starting to understand how health of, an older generation could still persist generations later?
The first thing, since you brought up the twins, I have to mention something about the twins. One of the examples I use for epigenetics is that about some people have estimated that 70% of identical twins have different fingerprints. Now, this is important because they have exactly the same genes. And they have different fingerprints because of their environment while they were developing in the womb. And that's because they shared the same placenta, but inevitably, one twin gets a little bit more of that placenta than the other. So they have different levels of nourishment. And somewhere in the range of 13 to 15 weeks, the nutrients that you're receiving will influence the number of swirls you have in your finger. And identical twins will have different swirls because they got different levels of nutrition.
I'm like so looking at my fingers right now.
Yes.
Yeah.
What are my swirls like?
Right. And the reason that I bring that up is because that shows you that those two twins had different nutrition. And epigenetics is a very powerful effect that is influenced by a person's nutrition. So people that are a little bit more malnourished or undernourished compared to another one might have different gene regulation for the rest of their life. And identical twins often die of different diseases. And that shows us automatically that it's not just all in your genes.
So one of the things that I still to this day, when I first heard of it, it just blew my mind. But the egg thing, let me rephrase that. So the 100-year effect, can we talk about that a little bit? It just blows my mind still.
Yes, I'm the best example in the world for the 100-year effect. It's a sheer accident, but I'm glad to tell the story. So before I tell you what it is, I have to remind you of the biology. The egg that made you or me was made in my mother's ovary when she was a fetus. So you have to get that. The egg that made me was actually made before my mother was born in her ovary. That egg was nourished, as was my mother as a fetus, by her mother across the placenta. So that means that the diet and environment of the mother, of the grandmother, affected my mother's, the way she developed, and the egg that made me, and gave the epigenetic opportunity for that egg to be modified, that is, the genes in that egg to be modified by epigenetic influences. And therefore, the risks for disease that I carry with me right now are in part determined by the epigenetic effect of my grandmother's diet on the egg that made me when I was in an ovary. The reason that this is called the 100-year effect is because from the time the egg is formed until it might show an influence on disease risk can be 100 years. The reason I'm telling you I'm the perfect example is because my mother died just a few months ago at the age of 99. And the egg that made me was made in her ovary almost exactly 100 years ago.
Well, it's almost your egg anniversary then.
It is. And I often say in egg years, I'm 100.
Those of our patients who are trying to get pregnant now, the eggs that are in their ovaries right now were formed while they were fetuses in their mom's belly.
And I know that's one of the things that can sometimes just make people feel overwhelmed. I mean, we talked about the 90s. So if we have listeners that are like, wait, I was a child of the 90s, and that means my mom was maybe eating a lot of processed food when she was pregnant with me. Does that mean that my children are destined? What do you do if you realize you have that exponential graph shooting up and our society is not as healthy now as we wish that it had been 100 years ago? How do we think about reversing any of these trends?
The one good thing about epigenetics and its powerful influence compared to genetics itself, that is the gene code, is that the epigenetic regulation of genes can be modified all through life, and it can be improved. And so these regulatory mechanisms can be reversed even if people have a history where those modifications might make them vulnerable for disease. And that includes many of us, by the way. We're not in this alone. Our society has become very vulnerable for chronic diseases, and the American Diabetes Association says that by 2050, 1 in every 3 people will have diabetes if we stay on the trajectory that we're on now. So the important thing is that we all know we have these vulnerabilities, but the good news is that a lot of these epigenetic changes can be reversible. And the younger you are when you try to reverse them by healthy diets and lifestyle, the more effective the reversal will be. So even for people my age, exercise and a good diet will modify epigenetic changes and make it more likely that I'll live a longer and healthy life. The really good news is that the younger you are, the more vulnerable you are for an epigenetic change. That is, even an embryo. Embryos are very vulnerable, fetuses are vulnerable, infants are vulnerable, children are vulnerable, and you've probably heard of the ACEs, the kinds of adverse experiences that children can suffer. Those have epigenetic changes as well. But those early stages in life are where people are what we call plastic. They're changeable. And we can change those epigenetic changes profoundly during those early developmental periods. However, what we need to know is that most people's habits and lifestyles are not set by intentionality. They're set by the environment in which they live. And people who live in environments where they eat poorly and that's part of their culture, then they will continue to do so. And that's why it's important for us to work at the community level, which we do through the organizations I work at OHSU, because it's time that we all start understanding we're in this together and we need to work together to help each other stay healthy and to have healthy children and grandchildren. So that's my little message.
Well, I love that you brought up the embryo part, because that's something that we certainly, being in a fertility clinic, talk about a lot with our patients. We have a very motivated population that, is very focused on getting pregnant. And so sometimes the thought can be, fastest path to pregnancy. What can I do to get pregnant right now? And we spend a lot of time talking about the importance of being in that healthiest state before pregnancy. So if there are lifestyle changes that someone wants to make, let's work on those before we put that embryo in there. As well as we have people who are building their family after using the genetics from someone else. Maybe they're having to or choosing to use egg from an egg donor, and that can be a little hard to feel that they don't have that genetic connection. So I often bring up epigenetics as a way of reviewing, actually, you're still really contributing to what the, expression of genes is going to be when this child is born, because by being the one who's carrying the pregnancy, you do have this control over the health of that developing embryo.
Wow, that is a really great point. And one thing that we've discovered in human studies, as well as studies in other species, is that it's really important to have a body that's ready for pregnancy. And that means, as much as possible, eating a healthy diet and having a healthy lifestyle and reducing harmful stress before the pregnancy begins. And that's in a person, whether they're going to be a recipient of an egg or whether they are going to have their own egg that will be fertilized and grow into a baby. And we say that 6 months to a year is really an important time before pregnancy, because there are good data that show good nutrition during that period of time makes a real difference. And I want to emphasize a point you already made there, and that is that building a body, being ready for pregnancy, it doesn't matter where the egg came from. The uterus is going to be affected. The fat stores, the vitamin stores, all the minerals in the body will be replenished and ready for the pregnancy if people can think ahead and be ready for it.
Well, I remember back in the 90s, since we're talking about 90s science, that was also cloning and Dolly the sheep. And I remember some story where they had a cat where it was the clone, and yet the fur pattern was different than what it should have been. It did not exactly match the mother. And they were saying, well, that's because the environment matters too. I think we want to see that influence as a source of power and excitement instead of just feeling scared about what we might already be destined to because of our grandparents' choices.
That's a very good point.
So what are some of the big, actionable items when you're trying to talk about, I guess it's really, like you said, the population level, because we want those healthier communities. It's not just individual choices. A lot of people can have all the good intentions in the world, but if they don't have the time or the space to safely have physical activity, if they don't have access to fruits and vegetables that are actually affordable and accessible, what are some of the groups that you're involved with trying to do at that population level to improve community health?
Well, thank you for asking. In Oregon, we have a program called the Nutrition Oregon Campaign. And there are a few other communities, but not many, around the world who are trying similar things. The most successful are people in the Netherlands, and they've really done a good job of working in communities to improve the health of people. And they study fertility too, by the way, so they have a nice way in which these two ideas come together. I think that what we're trying to do is to talk with health kinds of leaders in people's communities. And we want them to realize that they have the power to help change the community in such a way that people will improve their lifestyles and eat healthy diets. And without that, this is never going to change. There's not any, public or governmental advertising campaign that's going to fix this. And we are headed with, I've already mentioned the increases in diabetes, which is the bellwether for health in this country. I have a colleague that says we're headed for a train wreck. And what does the train wreck look like? Well, the locomotive is moving along and people's health is getting worse and worse, and the healthcare costs are going up and up. The American Heart Association is suggesting that it will double in the next 15 years. That is the cost for heart disease. And if that's true, we will hit the place where we will not be able to afford the kind of insurance required to care for so many sick people. So that's the train wreck. It's financial, but it's also personal of all these people who are going to suffer these diseases. So we have to do something. And one of the things we can do is be involved with our communities to make sure that they are working on the local level to help people live healthy lifestyles. And we focus mainly on pregnant women, even people who are pregnant who identify as men and they are carrying a baby. It's nevertheless important for good nutrition for them as well. So I just want to make sure that we know that we can't leave anybody out in our conversation for people who are pregnant, because that is the way in which this curve can be bent, and we will never reach that dire prediction that the American Diabetes Association says that we're about to do. So I just want to know that there is a ray of hope for me, and that's why I spend all my time trying to talk to people about this. We have to change it.
When I like the idea of community engagement, there was just an article in the New York Times last week where they looked at if individual providers were trying to have conversations about every single health guidelines with their patients, they need like 27 hours per patient, because we have these big picture guidelines for what we know is optimal health, but it's not realistic in an individual one-on-one 15-minute clinic visit to fix it. We need walkable communities, we need safe spaces, we need better food chain issues. I mean, there's all these big community level issues. But for our individual patients who are really just hoping to be pregnant sometime soon, I guess they have to work within the communities they're currently in. And so understanding these choices and the importance of epigenetics hopefully makes people feel at least that they have some ability to start preparing themselves in the best way.
Yes, I might add to that, and that is that both community health workers and doulas have been shown to make a very significant difference in the success of a pregnancy. And so that's another thing communities can do, is to make sure everybody has access to a person who cares about them during their pregnancy and helps them be as healthy as they can be during that time.
Yeah, that brings up a really good point too, because one thing that we have to be careful about is not to blame women for the health of the society, right? Like, we have to make sure that we know it's a societal issue, and men also have a role in this as well. But knowing that we do have the ability to change things, and we can be empowered to hopefully make our future generation better, which I think is what everybody can get on board with.
Women are not at fault for living in the community they live in. And that community is really the environment that determines what kind of lifestyles people live.
And I was just saying that brings up another good point about epigenetics, the challenge with issues of health equity, that when we look at health disparities and especially poor maternal health outcomes, It's hard to separate the fact that there is already such an unequal distribution of access to those health promoting situations that we know are out there, combined with all the issues of racism and stigma. I mean, it's really overwhelming if you think about it. And that's why it can seem so hard to reverse these trends.
I'd like to recommend a book that just came out by Monique Rainford, Pregnant While Black. In it, she highlights the disparities between African American women who deliver babies and those that don't, and the detrimental outcomes for the people who are Black. One of the key features of that, and she makes the point through discussions that she's had with me, that that's likely epigenetic, and that my own personal opinion is that it's left over from slavery. And we have not been able to reverse it by providing healthy environments for people who are now suffering.
Yeah, that's that question of like, can memories be passed on generation to generation? It's that generational trauma effect that can change how our genes are expressed.
Absolutely right.
One of the things that I think we should touch on is how can we change the epigenetics? One of the studies that comes to mind is, I can't remember the name of it specifically, but I remember the image of the yellow mouse, the big fat yellow mouse, and then the skinny little brown mouse. There is a difference between the nutrition in those mice.
That's right. They were genetically identical, and the mothers of the offspring either ate a well-balanced diet from leafy green vegetables and other foods that were given to give a balanced diet, and the other one had a poor diet. The big mouse that was yellow and fat suffered from obesity and a change in its hair color due to the fact that there was an epigenetic change in the gene. That was really the first example of the power of nutrition in changing genes, and it brought it to light for everybody because there were a lot of skeptics out there before that experiment. A lot of people didn't think food mattered. But it turns out that what we eat is very powerful in determining our epigenome.
And that's something that we eat every day. So that gives us a lot of opportunities to start to improve.
There's opportunities, multiple times a day. So you don't have to get it right all of the time. But when we're thinking about what's really healthy to put in our body that can help our genome function the way that is going to be best for our health, you're thinking those whole grains, those nuts, seeds, legumes, fruits and vegetables, especially those leafy greens. I could dive into the methylation and all of the histones and stuff, but I think it'd be way over everybody's head. But I tend to get a little bit nerdy about that. It's just fascinating. What you eat every day can change how your genetics actually work.
The list you just gave is the list I always give about what constitutes a healthy diet. I also add healthy oils like olive oil and avocado oil are excellent plant-based oils that are very healthy. High levels of saturated fat that comes from animal products is quite dangerous. And I think that that's one of the problems we have is that people develop tastes for having a certain kind of menu for dinner, and they don't want to switch very easily. But what they learn is if they can be around people who know how to cook, it doesn't take long to start liking a healthy diet. And so I'm very encouraging for people to try it and to stick to a simple one. It doesn't take rocket science. You shouldn't buy a book on how to eat healthy because they're all fad diets. You should eat fruits and vegetables, legumes, nuts, and fruit and healthy oils, and stay away from high levels of sugar and refined carbohydrates and fats that are saturated.
Dr. Thornburg, anything else you want to make sure that we get in?
This has been a pretty thorough session, and I appreciate the questions that you've asked. And of course, if there's some way that I can address questions that people have from among your constituents, I'd be glad to do that.
Yeah, well, we definitely, people who are listening, burning questions about epigenetics, you can send us an email and we could always do another update. We love to get these listener questions because I think it is something that a lot of people have not really thought about. It's a hard issue. I mean, there's, as much as we'd all love to have our garden out back, we don't. And so it's really hard in today's modern world to try and get back to those principles of the way that we wish we were eating. But I think you're right. It doesn't have to be too complex. And everyone's going to have what works for them, and some changes are still better than no changes too. So we don't want people to feel overwhelmed.
One thing we're trying to do is educate healthcare providers to talk to their patients about this, and especially people in the obstetrics and family medicine world that will be dealing with pregnancies. This is really important because people take seriously questions that their doctors ask them. And that's a lot better than seeing an ad on TV for eating right.
Definitely. Well, thank you so much for all your time today. It was truly a pleasure.
You can hit us up on Instagram at the Whole Pineapple Pod. We will see you next week. Thank you for listening.
Thanks for joining us for this week's episode of the Whole Pineapple Podcast. We hope it was helpful.
If you know someone who could benefit from hearing the podcast, we hope you'll share it with them.
And don't forget to subscribe, rate, and review The Whole Pineapple on your favorite podcast app. Every rating and review makes us easier to find.
This podcast is sponsored by Seattle Reproductive Medicine and is produced by Audiotocracy Podcast Production. We'll see you next time. Have a delicious week.